Start. Okay. So question 1 done. Question 2 done. Question 3 done. 4 done. Okay, now we start at 5. Okay, come, we continue from 5. Okay, check your answers. The statement below explains several situations. Mark tick the statement that involve kinetic energy. Okay. Um, Tanusha? Ah,
2 and 4.
2 and 4. A car parked in front of the house? Definitely no. It's already we tell park. Okay, kinetic energy is something moving. Okay, moving. So number 2, yes. Number 3, a horse grazing the grass. It is not moving. A swimming dolphin, yes. All right. Question B. Question B. State the two factors that influence the kinetic energy. Samira? Samira?
So, what page is this? I don't have this page.
You got print or not? Last week we already done. Part of it. Chapter 7 exercise part 2.
Page
Page 16. Got.
Hmm, no, sir. I print all.
Okay. You misplace it.
Hmm,
Never mind. You can take a paper and write down the answer first.
okay, sir. Sorry, sir.
It's okay. All right. So, let me tell you the answer. Okay, state two factors that influence kinetic energy. Whenever they're asking factors, what is the factor affecting pressure? What is factor affecting this energy, that energy? Whatever they're asking, what is mean by factors? Through the factor, they develop the formula. Remember that. Huh? We got a specific formula for pressure. We got specific formula for kinetic energy, for potential energy. How does this formula all developed? It developed based on the factors. Okay. Example for kinetic energy, kinetic energy, the formula was half mv square. So we know that this m for mass and v for velocity. So throughout this formula, okay, we can determine readily the factors that influencing the kinetic energy, which are the mass of an object, mass of object lah. Don't write just mass. Okay, mass of object and velocity of object. Okay, mass of object, velocity of object. 2 marks. Okay, and then we see the next question. Now, both vehicles P and Q in the diagram below move with the same speed. They already tell move with the same speed. That is 140 kilometer per hour. Okay. However, the kinetic energy possessed by vehicle P, that is the lorry or truck, is much higher compared to vehicle Q. Explain. Okay. Again, look at the formula. Half mv square. Okay, so they already tell the velocity is the same. Okay, so don't bother the velocity. We see the energy and the mass. When you bring energy and the mass at one side, it will form a division relationship. Whenever you get a division relationship, okay, yang ni constant kan, velocity dia constant, so tak payah tengok di sini. Kita nak compare yang ni saja. Whenever you see a division relationship, that means it is directly proportional. What is mean by directly proportional? I got talk about this before. That means if m increase, your kinetic energy is increased. When your m is down, your kinetic energy also down. Okay, must follow each other. Kalau A naik, B turun, ataupun A turun, B naik. This one you can see it's opposite to each other, right? This one we call inversely proportional. Inversely proportional. Kalau dia follow, kalau A naik, B pun naik. Kalau A turun, B pun turun, that one we call directly proportional. Kalau inversely, the relationship will be normally multiplication. Kalau directly proportional, it will be divide. Okay, division. Okay, so we can see a division relationship. So that means why this one, your P is higher kinetic energy due to its mass. Okay. Okay, so however, the kinetic energy of vehicle P is much higher. Explain why. Okay, vehicle P has greater mass compared to vehicle Q. Okay, vehicle P has greater mass compared to vehicle Q. Higher or greater the mass, higher the kinetic energy. And that explains why our vehicle P possesses a much higher kinetic energy. Okay, vehicle P has a greater mass compared to vehicle Q. Therefore, greater the mass, higher the kinetic energy. Okay, so that will be the explanation for that. Okay, please copy down. Okay, now we go to question 6. Question 6 is about principle of conservation of energy. Remember, principle of conservation of energy tell us what? Energy cannot be created or destroyed. Yes, that is true. And energy can be transferred from one form to another form. These are the only sentence that related to our the principle of conservation of energy. Okay, and then we see more about statement 2 and 3. Why is it wrong? Energy in an object will reduce when the object is heated. Not necessarily. When an aeroplane is landing, the gravitational potential energy increases. Landing means your height is decreasing. Landing means your height is decreasing. Therefore, you punya gravitational potential energy must be decreasing, not increasing. This is wrong. Okay? So the answer will be 1 and 4. Okay? So I proceed to the next part. Next part. Mesh the diagram below to the energy change that occur. Okay, this fella is going up, the height is increasing. So this is related with the height. So this is gravitation. They're asking what are the energy change. So this one is he's moving his bicycle and he going to reach at the peak. That means he's moving first. That means kinetic energy first. Once he reach at the top of the mountain, then it is due to height. So potential energy. So kinetic energy to potential energy. And for the slider guy, he is at the top ready. So it is potential energy first. Then he going down. So he going to move. Then it is a kinetic energy. Therefore, the energy change that will most probably take place here is potential energy converted to kinetic energy. Okay. Next question. Diagram below show a toy trolley with a mass 1 kg sliding down a steep. Okay. At position P, the potential energy possessed was 50 joule. Okay. At position P, dia cakap 50 joule lah. Dia punya apa? Potential energy. Okay. How much is the kinetic energy at point Q if the potential energy is 20 joule? Okay. That means they're asking how much is the kinetic energy here when your potential energy is equal to 20 joule here. So you must understand first. You must understand the, previously I teach you the, what do you call the one, pendulum bob. The bob, you remember the bob? Okay. uh, when it reached the maximum height here, your EP is maximum while your kinetic energy is zero. Remember that. Okay, so same here, this is your maximum height, so your EP is 50, so your EK is 0 joule. Okay, your EK is equal to 0 joule here. So when coming here, so it totally make up to 50 joule lah guys. So kalau dekat sini potential dia 20, your kinetic energy should be 30 joule. Make up the 50 joule again. Okay, part of the potential energy is being converted to the kinetic energy. Okay, because we know that the total energy cannot be destroyed, cannot be gone like that. Okay, it will be transferred from one form to another form. So the potential energy that lose by the trolley is gained by the kinetic energy. Okay, so simply take your 50 joule, you minus the 20 joule, so you're getting 30 joule of kinetic energy. Okay, 30 joule of kinetic energy. Banyak orang dia fikir how to calculate this. They never give us the velocity or how to calculate the kinetic energy. No need. You must understand the concept of principle of conservation of energy. Then you should understand this. Okay, you can imagine. You can sketch out this working. Okay. So remember that the total energy should be the same because the பேர்லயே இருக்கு பாருங்க, பேர்ல என்ன சொல்லிருக்காங்க, conservation means making same, making as normal, making as usual. அதான் the conservation ஓட அர்த்தம். So 50 was the so you conserve to be 50, so the value won't change. Okay, next question number 7. Any question please ask me. Okay, question number 7. Hold on, scan. 1 minute. Okay, name the potential energy in the both picture. Okay, they already tell both are potential, but we need to tell what kind of a potential energy they are illustrating. Okay, for the first one, you are stretching a slingshot. Stretching due to stretching or compression, compression or stretching, extension. You heard this kind of word, we immediately know it is the elastic potential energy. Okay, elastic potential energy. Can I write elastic energy? You can actually, but it is not advisable. I'm not encouraging you write halfway of the answer. Write elastic potential energy. It will be a good choice. And if you do, if you're sitting on a branch, okay, on a high position, that means you're automatically having gravitational potential energy. Gravitational potential energy. And the subsequent question ask us, differentiate the potential energy in A and B. The potential energy of the situation A is due to stretching or compression, while for B is due to the position, especially high position. Okay, we're gonna explain this. So differentiate, okay, let us differentiate. The potential energy, if your answer similar, sound similar, or you need a verification, you just read out your answer. Okay, the potential energy in A is due to the object that is compressed or stretched, while the potential energy in B is due to the height from the earth. Okay, is due to height from the earth. Okay, that will be my answer. Question C. In situation A, the work done by the boy to stretch the slingshot was 30 joule. Okay, you say the work done is 30 joule. Remember, your elastic potential energy is half Fs or Fx. X representing the extension or compression. And here the potential energy is half potential energy is mgh, sorry. Okay, now what was the question? The work done by the boy to stretch the slingshot was 30 joule. State the amount of potential energy that is possessed in the slingshot. Should be same. Okay, should be same because wait. In situation A, the work done by the amount of potential energy. I mean, okay. Now I already told you that work done is equal to energy. I already told you so many times, right? So the work done was 30 joule. How much will be the elastic potential energy? Definitely 30 joule. Okay, definitely 30 joule. You don't need to think a lot. So because why you need to write the answer? Because the work done by the boy to stretch the slingshot is equal to the elastic potential energy. Okay, because work done by the boy to stretch the slingshot is equal to the elastic potential energy. Yes, someone. I have this paper until last page, sir. Okay, that's good. Can write down the answers.
Then, sir.
All right. Question D. It doesn't end there. The diagram below show a mother bird feeding its young. Okay, we can see the mother actually. Give a good observation. You can see the mother with the four little birds. Okay, in a nest of a tree. Calculate the gravitational potential energy of the bird nest. Given the mass of the nest with the young is 1000 kg. Okay. Given the mass of the nest with the young is 1000 kg. 1000 grams, sorry. So all is okay, but does it include the mother of the bird? I'm looking for it, but unfortunately it's not here. So it's a normal question. Gravitational potential energy. That's what they ask us to calculate. So we write first the formula. Always initiate with your formula. mgh. So the mass was 1000 gram. Always remember, whenever you want to use formula, make sure you are using SI unit. You are not allowed to use any other unit. Try to use SI unit. So your mass is 1000 gram. You cannot substitute 1000 because gram is not SI unit. So it is 1 kg. So 1 kg, the G is 10, always 10 for your level. When you go to higher level, you will write 9.8 or 9.81. Okay. And the height was given 3 meter. Okay. So 30 times 1 is 30 joule. Remember, for energy and work done, the unit is joule. Next question. Calculate the kinetic energy of the 2.1 kg mother bird when flying to find food for its young. Given the velocity of the mother bird flying is 20 meter per second. Okay, meter per second is SI unit. 2.1 kg is SI unit. Okay, that's good. So let us plug in the formula. Kinetic energy is equal to half mv square. So half, the mass was 2.1 kg and the velocity was 20, and don't forget to square it. Sometimes you square here but you not square at your calculator. So beware of this kind of mistakes all. Okay. So let's calculate this, and you should get 420 joule. 420 joule. Okay, next question. Question 8. Name the type of potential energy possessed by the object based on the situation shown in the diagram below. We already done this kind of a question. This is due to height. So this is a gravitational potential energy. Gravitational potential energy. And this is due to stretching. So it should be elastic potential energy. Okay, now listen the question carefully. Okay. Now we see this. Okay, we got something new here. SWG. Okay, we'll see that. Zahid carried out an experiment in laboratory to determine the elastic potential energy possessed by the spring with different thickness. Alright. The thickness of the spring are indicated by the value of SWG. What is SWG? It is the standard wire gauge. And it is also known that the smaller the SWG value, the thicker the spring is. Okay. Smaller the SWG value, thicker the spring is. The diagram below show the position of a ball when released after being compressed with the spring. Okay. So you compress this ball and then you release it, extend until 4 centimeter when you are using the SWG 34, and the force was measured to be 5 Newton. Okay, those are the data that we can collect here. Now, calculate the elastic potential energy possessed by the stretch spring M. Okay, elastic potential energy. Oh, this question is very generous. They give us the formula. Okay, very good indeed. So the extension was 4 centimeter. Can you see? Okay, because you compress until 4 centimeter here. You compress until 4 centimeter here and then you release. Okay, so the compression or stretching is known as the X. And the force involved here is 5 Newton. Remember that. So 1 over 2, the force was 5 Newton. And the extension was 4 centimeter. Beware of this trap. I already told you, make sure everything SI unit, standard international unit. So centimeter, you divide 100, you get 0.04 meter. Okay, alright, so 0.04 meter. Now we see what will be the answer. The answer you should be getting is 0.1 joule. Okay, 0.1 joule. Moving on. Zahid repeat the experiment by replacing the spring M with the spring N. You want to replace the spring M dengan spring N pula sekarang. With the thickness of SWG 20. Predict the elastic potential energy possessed by the spring N and the distance of the ball bouncing. Oh, okay. We need to predict two things here. Okay. So, okay, they already tell us SWG, when the SWG is smaller, thicker the spring. So you need to think, when the spring get thicker, is it going to extend more or less? Okay, that's what we need to think now. Okay, so let's see here. From if 34, if I use 34 SWG, the extension was 4 centimeter, and the force was 5 Newton. Okay, so let us do a small data here. Okay, we do a small data first. SWG is here, force is here, and x is here, the distance of ball bouncing. Okay, so if I use 34, the force was 5 Newton, and the distance was uh, 4 centimeter. Okay, now you are using 20. You are using 20, so that means when your value is getting stronger, sorry, smaller, the smaller the SWG value, thicker the spring. When the spring is thicker, it can support more. That means your extension will be decreasing. uh, your extension should be decreasing. So let's say it will be 2 centimeter like that. And your force should be increasing. Your force will be little bit increasing. Okay, but then they're asking the overall elastic potential energy. So I think the force is not needed here. We need this energy. Okay, this one I put energy lah. When your x is decreasing, your energy is automatically decreasing. Because you see your formula, half fx is equals to energy. So energy and the extension you bring at one side, that the force is equal. Okay, so hubungan bahagi maksudnya, when your extension go down, your energy also go down. Very clear, right? So here this one is 0.1 joule. So here should be a bit 0.05 joule. Okay, so what we can explain here is the elastic potential energy should be less than 0.1 joule. And on the other hand, the distance of the ball bouncing is less than 4 centimeter. Okay, it must be less than these two values. Okay, 1 mark, this one 1 mark. Okay, please write whatever necessary for you. I'll wait for you. Once done, tell me done.
Done, sir.
Done. Okay.
So not yet, sir.
Not yet. Okay, okay.
Okay, done, sir.
Okay. Now, so we can see when the thickness is thickness is increasing. First of all, your SWG, if it is decreasing, that means your thickness is increasing. That means your potential energy is also, when your thickness is increasing, your potential energy also decreasing. Okay, now we got spring L SWG 28 pula. Okay, so you need to arrange all the spring in ascending order of elastic potential energy. So okay, so just now we see 34 and 20, now in between 28. Okay, so this one is extend until 4 centimeter. So highest potential energy is at your 34. Here it will be even less, 22 centimeter. Here maybe 3 centimeter lah. Okay, we want the elastic potential energy. So we kita agak-agak je lah. Yang ni 0.1 joule. Here you put 0.05 joule. So in between 0.025 joule is here. So your 28 is confirm nadula. Confirm in between the 34 and 20 lah. So spring L is here. Now you introduce another spring with SWG 28. So yang paling tinggi adalah spring M, which is having 34 SWG, and paling low adalah spring N. Okay, NLM. Your potential energy is decreasing in this way. So what is the conclusion we can make here? When your thickness is increasing, elastic potential energy is decreasing. Okay, thickness is increasing, elastic potential energy is decreasing. We can see from here clearly. So increase. This is a bit out of topic actually. Yeah, the factors affecting the spring elasticity all not in your syllabus, but we can do. You can consider this as a K-part question. Okay, increase the thickness of a spring, comma, decrease the elastic potential energy possessed by the spring. Done?
That's
Okay. Next question. Okay, next question is look like what, a roller coaster is it? Okay. During the last school holiday, Kamal and his family went to a theme park. The experience of a roller coaster ride was fun. Was fun. The diagram below show the roller coaster ridden by them. The roller coaster start at P and finish at W, and the car was stopped by hitting the bumper. Okay, once it hit the bumper, it will be stopped. Okay, now mark tick in the box provided in the diagram. At which position the roller coaster has no kinetic energy. Your kinetic energy is equals to 0 when your potential energy is at the maximum. This is what I teach according to the textbook. So your maximum position will be P and also your R. Okay, P and R with maximum height, so we don't have any kinetic energy over there. Based on the principle of conservation of energy, explain the amount of energy and energy change that take place. Mhm. They never give anything. They know what to explain. Based on the principle of conservation of energy, explain the amount of energy and energy change take. Okay, energy change we can tell lah from potential energy and it move on to the kinetic energy. But how come they never give anything and they ask us to explain the amount of energy? Oh, they ask us to explain. Mm, how I'm going to explain this? Okay. All right. This one, give me a minute. I need to think a bit. Okay, I can explain the energy change ready because the energy change is from potential energy to kinetic energy, very clear. And I'm quite unsure about they didn't give any value to explain how to explain. Okay, see, differentiate the gravitational potential energy and the kinetic energy at P. Okay, we need to differentiate. Okay, so at P and at T. Okay, you need to differentiate the gravitational potential energy. Okay, at P, the gravitational potential energy, the gravitational potential energy is maximum. Okay, it's the maximum because due to its maximum height. Okay, we explain it also. Due to its maximum height at okay, I think I miss here at P. Okay, now at T, the gravitational potential energy is the gravitational potential energy is where is it? Is the minimum, not zero. We cannot write zero. Is minimum. Okay, there is no such thing as a gravitational potential energy becoming zero. Okay, so gravitational potential energy is minimum due to its lowest position, okay, or lowest height. Okay, so I already tell differentiate and also explaining why. Okay, actually they asking differentiate and they should put explain, then only 2 marks. Okay, so next question. Okay, next question is asking us about the you know when the car splashed through water at T. Okay, that means it's spraying some water. Is it when the car splashed through the water at T? Oh, there is a water here. Okay, okay. That's why I'm thinking, why there is a water? Why is this car water? Okay, there is a water here. Okay. All right. It start to move slowly. What is the force act on the car to slow it down? Explain. ஸோ நீங்கள் வாட்டர் போட்டிங்கன்னா அதுக்கு பேர் வந்து வாட்டர் ரெசிஸ்டன்ட் சொல்லுவாங்க. ஓகே, வாட்டர் ரெசிஸ்டன்ட். அதுவே நீங்கள் பறக்கும் போது ஏர் ரெசிஸ்டன்ட். Oke ya. Kalau ke udara kita cakap rintangan udara, kalau ke air kita cakap rintangan air. Oke? Water resistant. Oke, and I think I misread the question again. Okay, differentiate the gravitational potential energy and kinetic energy also they tell us. Okay, never mind, just add one more point. Sorry, I just நம்ம எல்லாம் கரெக்டாக செஞ்சுமா இன்னும் ஒன்று மிஸ் ஆகிற மாதிரியே இருக்குன்னு தோணுச்சு. Okay, it is here. Okay, let's see here. Okay, so you want to differentiate kinetic energy, very simple. At P the kinetic energy is 0. At T it was the uh, I can tell it's maximum. Start from after the T only it going to decrease. Okay, so at P kinetic energy, okay, kinetic energy is 0, while at T the kinetic energy is maximum. When your potential is minimum, that's where the kinetic energy is the maximum. Okay, so that's a point you need to add on. And coming back to here, they're asking two forces. What are the forces act? What are the force? What is the force act on the car to slow it down? Water resistant. Okay, why it doing the slowing thing? Okay, because water resistant water resistant is a type of friction force, is a type of frictional force that oppose the direction of motion, that oppose the direction of motion. Sir, is buoyant force is related with the floating of object, not here. It's about floating. Buoyant force is about floating, remember that. And it is not only in the water. Many people misconception is buoyant force வந்து வாட்டர்ல தான் இருக்கும். கிடையாது. Buoyant force is in the liquid and in the gas. Example, your hot air balloon is floating on the air means the buoyant force is higher there. Okay, your floating of a hot air balloon also influenced by the buoyant force, remember that. Okay, now coming back to question B. அவங்க என்ன கேட்குறாங்க வராங்கன்னா I read again the question. Based on the principle of conservation energy, okay, principle kabadi antunaga, explain the amount of energy and energy change that take place. Oh, I think this is not based on this diagram. Remember, I tell you, your potential energy, we got two things to learn, okay? Energy cannot be created or destroyed. Okay, this one, okay. And our principle of conservation of energy also tell that energy can be transferred from one form to another form, okay? And I do add the point that conservation means making the thing same, right? So the amount of energy is the same, constant, won't change. And the energy can change from one form to another form. So we need to explain the principle of conservation of energy basically here. That's what I can understand from this question. So the amount of energy is constant. I just explained conservation means constant, and the energy change will take place from one form to another. Okay, from one form to another form. For instance, we give an example. For instance, kinetic energy and potential energy in this case lah, and potential energy. Okay, the amount of energy is constant and the energy change will take place from one form to another form. For instance, kinetic energy and potential energy based on this case. Okay, hope you get all the points here. So எல்லாத்தையும் எழுதி முடிங்க. Okay, average force. Okay, 0.75. Moving on, explain briefly two example of application of the properties of elastic potential energy in daily life. You need to explain. What do you want to explain briefly about application of properties of elastic potential energy? One you can explain about stretching, another one you can explain about compressing. Okay, what stretching example we can tell? Okay, like you know, you make the, what do you call, you place the baby into a cradle to let it sleep. You know, you need to use the kind of spring totil lah. Okay, but very hard to explain this. How you want to explain? Explain briefly two example of, okay, you are using the stapler pin, stapler, sorry, using the spring inside the stapler. I'm very sure this one we can find in our textbook. Okay, wait, jom kita cetak rompak dari textbook. Okay, alright, see here. Photograph 7 show the step to refill a stapler with staples. There is a spring that is stretched and then released. The force is produced by stretch spring. Move the staple in the direction of the force. So the activity is refill a stapler with staple. Okay, this is your first point. And how you explain that? The force produced by stretch spring, move the staple in the direction of force. This is the second point, guys. Write these two first. Okay, the first point is refill a stapler with staple. That is our daily activity. Another the explanation for that is a force is produced by stretch spring. Move the staple in the direction of the force. That is upward lah. Okay. Write this down. I find another example for the compression. Compression, we can tell what. For a sponge, maybe a sponge, or maybe where we compress things. Okay. Okay, the third point I use here lah only. Okay, the third point okay, compression. Compression example I use the sponge lah. When we when you do our dishwash, we will compress the sponge. Okay, we'll compress the sponge. Okay, compressing. This is example of stretching. Now compressing what? Compressing a sponge when carry out dishwash. Okay. Now we copy the thing lah. The force produced by compressed sponge. Okay. Help to retain its original shape. Okay, the force produced by compressed sponge help to retain its original shape. Example, அந்த compress பண்ண force வச்சு அது திருப்பி அதோட rupa sebenar, dia akan kembali kepada bentuk asal dia. These are the 4 points. Alright, so we go to the next part. Okay. Next question. An athlete throw a disc of mass 2 kg with a speed of 20 meter per second. Calculate the energy, kinetic energy. Okay, kinetic energy always initiate with your formula half mv square 1 over 2. The mass is 2 kg. The velocity was 20 meter per second. Make sure it's a meter per second. And don't forget to square in your calculation and your calculator. Okay. So 2 and 2 cut. So 20 square is 400. So I assume the answer is 400 joule. Okay, 400 joule. Next question. State 2 important properties in principle of conservation of energy. Okay, we know that energy cannot be created or destroyed. Energy can be transferred, or you also can write can be converted. Okay, energy can be transferred or converted from one form to another form. Okay, question B. Okay. Okay, let's see. Figure 7a show a durian fruit falling from a tree in Maheswaran Orchard. The durian fruit fell from a height of 14.4 meter and was weighed as in figure 7b. Okay, so we know the height is 14.4 meter and the weight should be what? Okay, let us see here. This is 1, 1.2, 1.1, 1.2, 1.3, 1.4, 1.5 lah, tengah-tengah kan. So 1.5 kg lah guys. Remember that? Okay. Now, name the energy of in the durian fruit that is still on the tree. Still on the tree is due to height, right? அப்ப அது உயரமான இடத்துல இருக்கு பாருங்க. அப்ப gravitational gravitational potential energy. And what is the value of energy in B1? It is given that gravitational acceleration is 10. G lah, G is 10. Okay, value of energy. So the energy they mentioned here is potential energy, which is equal to mgh. The mass was 1.5 kg. Gravity was 10. Height வந்து 14.4, right? 14.4 meter. Make sure everything in SI unit. Remember for distance all meter is the SI unit, not kilometer. Okay. Jangan silap pula. Okay. And the mass was 1.5 kg. Okay, good. Now let's calculate this. 1.5 times 10 times 14.4. So I'm getting 216 joule. 216 joule. Next question. Explain the change in energy that occur when a durian fruit fall from a tree to the ground. So we need to explain the change. Okay. So the energy change is from gravitational potential energy to kinetic energy. Okay. So initially, we need to explain this. Initially, the durian position is at durian. How to tell? Durian is position. Initially, the durian was uh, at higher position. Was at a higher position. So the potential energy, gravitational potential energy is maximum, and when the durian fall from the tree, the gravitational potential energy is dropping while gaining kinetic energy. A bit lengthy. While gaining kinetic energy. But in the exam, I assume that they will ask you what are the changes only. They will never ask you to, explain things like this. Anyway, it's a good exercise as well. Initially, the durian was at a higher position, so gravitational potential energy is maximum. And when the durian is fall from the tree, the gravitational potential is dropping while gaining kinetic energy. Yeah, that's why it is converted from gravitational potential energy into kinetic energy. Okay, now our question based on the principle of energy performance. Permanence la illa. I think the Google translate wrongly. Okay, principle of conservation of energy. Calculate the velocity of the durian before it reached the land. Show your calculation step. Why before it reached the land? Because after it reached the land, the speed will decrease what? Zero what? Stop ஆயிருமே durian move பண்றது. So அப்ப kinetic energy பாய்ச்ச அந்த velocity எவ்வளோன்னு கேட்குறாங்க. So we know that by okay, we must tell working like this. By principle of conservation of energy, comma, your gravitational potential energy is converted to kinetic energy. Therefore, your potential energy is equal to kinetic energy. That means your mgh is equal to half mv square. Okay, note that both places also got mass, right? Okay, you can cut like this. அதுக்காக இங்க m plus 3 equals to m minus 2 m இப்படி கட் பண்ண முடியாது. ஓகேயா, mathematically speaking this one. Okay, அதுவே m cos 3 equal to m cos இப்படி bracket 2. Kalau hubungan darab kita boleh cut like this. Okay, we can cut like this. ஓகே, ஸோ அப்படி உங்களுக்கு புரியலனா சரி, இந்த மேஸை வந்து நம்ம ரைட் ஹேண்ட் சைட் கூட்டிகிட்டு போனாக்கா இப்படி ஆயிரும்ல, அப்போ நம்ம வெட்டி தானே ஆகும். கரெக்டா? ஸோ இது கொஞ்சம் புரிஞ்சுக்கிறதுக்கு கொஞ்சம் நேரம் ஆகும் உங்களுக்கு. higher level நம்ம இப்படி வெட்டிடுவோம். Okey, sekarang kita nak cari V saja. Okey, jadi half ini kita tukar pergi sini. Okey, half kita tukar pergi sini, dia akan jadi 2/1. Okay, if you don't understand, I will make you understand, don't worry. GH 1/2 dia tengah buat apa di sini? Darab dengan V square. So datang sini dia akan bahagi dengan 1/2. So GH bahagi tu apa dia? Darab 2/1. Jadi GH times 2 ni எழுதலாம். அதனால தான் 2GH வருது. Okay, so that's why I told you that. So this half, when you go here, it become 2/1. That is 2GH equals to V square. Or you want to substitute first also can. நம்ம அதை வந்து சப்ஜெக்டாக மாற்றிட்டு அதுக்கப்புறம் சப்ஸ்டிடியூட் பண்ணுறது சொல்லித்தரேன். So you want the V only, right? So the square pergi sini dia akan jadi square root. So 2 darab 10 darab H dia 14.4. You akan dapat V. V dia berapa? 20 times 14.4 and then square root this, you get 16.97 meter per saat. Ataupun kamu boleh ganti semua dulu. Kalau kamu tak pandai move things around, okay, never mind. Okay, mgh is equal to half mv square. Question ni dia bagi mass. Kadang-kadang dia tak bagi mass pun tak apa, dia tak bagi mass pun tak apa, dia tak bagi pun tak apa, tak kisahlah, kita boleh potong macam ni. Baik, kita ada GH dengan V square. Okay, G dia 10, height dia adalah 14.4 and 1/2 V kuasa 2. Okay, and then 10 ini jadi 144 lah, bahagi 1/2 equals to V square. Berapa? 144 bahagi 1/2, kita akan dapat V square equals to 288. So V adalah 288 square root. Dapat jawapan yang sama juga. Okay, you nak ganti dulu baru you move sampai you dapat V, ataupun you nak move sampai dapat V lepas tu baru you ganti pun boleh juga. Dua-dua tak ada masalah. Jawapan dia sama saja, tapi make sure you put the unit correctly. Velocity is meter per second or ms negative 1.
Sir.
All right, question 7. How long is this? Okay, a few more. Question 7. This one all physics side. இப்படி தான் இருக்கும் உங்களோட physics questionலாம் next year போனீங்கன்னா. maybe even worse than this. Okay, yeah, it should be worse than this. This is just basic physics. Okay, but it will be very interesting to learn physics. Okay, among all the science, I won't say physics is easiest, but it will be challenging and make you think a lot. Okay, Your chemistry was easiest, I think. Among the three, chemistry was easiest. Biology, you need a good super memory, then I think. But memory alone is not, will be handy, you know. This time all we got K-But question, you need understanding as well. I see the physics, chemistry people can score A easily, but biology, they are struggling actually. Some of them get 9A and 1B. Where is the B? Biology B. So இதெல்லாம் ஞாபகம் வச்சுக்கிங்க. Next year நம்ம போறோம். So prepare yourself better. Okay. The diagram below show a pendulum bob is released and the energy transformation between the gravitational potential and kinetic energy. Okay. Soalan ni kita tengok. Why is why why is the gravitational potential energy of the pendulum bob maximum at position P? At position P, why is it maximum? Because the height is maximum. Because the height is maximum. Simple as that. Why the EP here maximum கேக்குறாங்க? Because the height is maximum. That's it. And why is the kinetic energy of the pendulum bob 0 at position P? Why the EK is 0? Because at maximum height, the pendulum will not move. At maximum height, the pendulum bob will be stationary. Stationary means did not move. இது கொஞ்சம் கிட்ட கிட்ட எழுதிக்கிங்க. Will be stationary. So dalam kurungan V equal to kosong ms. Okay, the speed is 0 lah. Next question. When you are going from P to Q, why is the gravitational potential energy is decreasing? P to Q நம்ம போறோம். Gravitational potential energy decreasing. Definitely lah, because the height is decreasing. Simple as that. The height is decreasing. That's why the gravitational potential energy also decreasing. Okay? Very easy to analyze this question all. Don't give up with this one all. Very easy one. Okay, now, why is the kinetic of energy pula increases? Why is the EK pula increases? Because the speed is increasing. Because the speed of, we don't use the speed, we use the velocity. Because the velocity of pendulum bob is increasing. That's why the kinetic energy also increasing. Okay? Because the velocity of the pendulum bob is increasing. Next. Why is the gravitational potential energy of pendulum bob minimum at position Q? Why the EP is minimum at here? They're asking. Because the height was minimum. That's it. Because that is the height of the how to tell? Because the height of the pendulum bob is minimum. Won't be 0, huh? There's no such thing as gravitational potential energy becomes 0. But kinetic energy can be 0 at maximum height. The height of the pendulum bob is minimum. Okay, the height of the pendulum bob is minimum. Why is the kinetic energy of the pendulum bob maximum at position Q? Because the speed is maximum at here. Speed சொல்றது நான் velocity தான் சொல்றேன். Because the velocity of the pendulum bob is maximum. Okay. Why is the gravitational potential energy of the pendulum bob, not lob, decreasing from position Q to R? Why the EP is decreasing from Q to R? From Q to R, Q to R, this one, right? Why they put decreasing? I think I misread the question. Okay, it's supposed to be Y is the kinetic energy. Y is the kinetic energy of the pendulum bob decreasing from Q to R. Yes, of course, Q to R, the kinetic energy will be decreasing because the velocity of the pendulum bob is decreasing. So the kinetic energy also decreasing. Okay. And finally, why is the potential energy of the pendulum bob increasing from Q to R? Can you see? From Q to R, height dia semakin bertambah. Okay, the ketinggian semakin bertambah, maka dia punya gravitational potential energy also increases. Okay, because the height is increasing. Because the height of the pendulum is also increasing. Okay, very quickly we can solve this.
Then, sir,
Done. Okay,
Done, sir.
all right. Come, we continue the question. Question 8, final question, presume. Yeah. Question 8, the diagram below show a closed spring swing system. Okay. I won't call it swing system. It should be oscillating system. Oscillating system with a load. Determine the following position. Okay. So your load is at here. It extends to Y and Z. Okay. So where is your maximum elastic potential energy? Your maximum elastic potential energy when you stretch to maximum, that is at Z. Where is your minimum elastic potential energy? Should be at your X. At X, masa dia tak stretch, kat situ minimum elastic potential energy. Where is your maximum kinetic energy? Okay, you know that this spring system, the energy change is between elastic potential energy and kinetic energy. Okay, so when I tell maximum kinetic energy, it should be minimum elastic energy, elastic potential energy. Okay, so maximum kinetic energy na minimum elastic potential energy, it's same as previous question, that is X also. The Y is just useless. Okay, now Vaishnavi released a ball with a mass of 500 gram from height 1.5 meter from the floor surface as shown in the diagram. G is estimated 10 meter per second. What is the gravitational potential energy? Okay, very simple this one. EP is equal to mgh. Beware of that, your 500 gram, not kilogram. So it is 0.5 kg. Gravity was 10. Height was 1.5. And when you evaluate this, I am getting 7.5 joule. Okay, 7.5 joule. Calculate the maximum speed of the ball when it is released. Okay, they're asking maximum speed. So this one you can use, we know that EP is equal to EK kan. EP is equal to EK kan. Jadi EP dia 7.5. EK senang je lah. Half, mass is 0.5. Now the V square is what they are asking. The V lah. Okay, so 7.5 is equal to 0.25 v square. So 7.5 divided by 0.25 is equals to v square. So v is equal to kita pergi square to opposite, it becomes square root. So 7.5, 0.25. Okay, use your latest calculator to calculate this, or use your traditional method to calculate this. Okay, so square root 30 lah. Square root 30, which is equal to around 5.48. Kalau bagi decimal yang terus dia datang continuously, take two decimal point enough. 5.48 ms negatif 1. Itu jawapan dia. Okay.
Done, sir.
Done. Okay, good.
Done, sir.
All right. Now, okay, something happening here. Okay. What is that? Diagram 2.3 show a group of men pushing a lorry and a man pushing a van. Why are more people required to push a lorry? For obvious reason. Okay, because lorry is heavier than a van. So a lot of force needed to overcome the frictional force. Why அது ஏன் நின்னுகிட்டு இருக்குன்னா அது friction நால நிக்குது. To overcome the frictional force held by heldனா hold ஓட past tense held by the lorry compared to a van. Okay, lorry is heavier than a van, so a lot of force is needed to overcome the frictional force held by the lorry compared to a van. Okay, next question. Explain why a fruit hanging on a tree is said to have no kinetic energy. A fruit that hanging on a tree is considered it is at the maximum height, Maximum height அப்ப நம்ம முதல்ல இருந்து சொல்லிக்கிட்டு இருக்கிறோம். Kinetic energy zero because the speed is zero there. Okay? When the fruit is at its maximum height where the velocity of the fruit is zero. Hence, the kinetic energy is zero. Okay? Hence, the kinetic energy is zero. That will be the answer. And finally, calculate the work done by her to pull the bow. Okay, this is elastic force, so half Fx. Don't forget your half. Okay, நிறைய பேர் work done பார்த்தோன்னே work is equal to force time displacement அப்படி போட்டுருவீங்க. தவறு. இந்த work வந்து to stretch, so it is equals to elastic potential energy EE. EE is equals to half Fx. Half போடலன்னா இந்த இடத்துல wrong ஆயிரும் answer. 300 Newton and your displacement was 0.3. So 650 times 0.3. 195 joule. I think you still have some continuation. Okay, at here. This is a textbook question, so we need to see about that. Okay. I don't know why it's N here. Okay. There, the continuation, the two questions here. Okay, so we see elastic potential energy, we get 195, 195 joule. Okay, now the next question. If the archery has a mass 200 gram, okay, and move at the velocity 60 meter per second, calculate the kinetic energy of the arrow. So kinetic energy is half mv square. So mass is 200 gram, which you need to change to kg, 0.2, and 60 ms negative 1. So it's a SI unit, don't need to change anything. Okay, you calculate this. And I'm getting 360 joule. Guys, if you see here, this is 195. And this one also must be 195 watt, according to the elastic pula. Apa ni, principle of conservation of energy. Dia kata energy dia mesti sama kan? Tapi kenapa dia tak sama? Okay. Now I'm going to give you the real explanation. Actually, அந்த principle படி நம்ம calculate பண்ணணும்னா, we will assume this energy and this energy is the same. Then only you can solve the things. But in practical, uh, in real life or in practically, this energy and this energy shouldn't be the same, because some energy will be wasted as heat energy. இந்த இடத்துலேருந்து இந்த இப்போ லெட்ஸ் ஏலேருந்து பிக்கு கன்வெர்ட் ஆகும்போது என்ன ஆகும்னா, சில எனர்ஜி வந்து akan dibazirkan sebagai tenaga haba, will be wasted as heat energy. So in real life, no way the energy is exactly the same. Okay, அதுதான் அடுத்தது கேட்குறாங்க பாருங்க. Explain why not all the work done to pull this bow change to elastic power, elastic energy lah, sorry, elastic energy. Why? Because some of the energy is wasted as heat energy. So நம்ம இப்போ சொல்றோம் principle of conservation of energy சமமா இருக்கும், that one for calculation purpose only. But in the real life example, real life application, there will be some energy loss, some energy is wasted or lost as heat energy. Remember that. Okay, so by completing this, we are done with our chapter 7. Let's roll into chapter 8. Okay, very interesting chapter. Again, emphasizes on the physics field. Okay, I hope everyone finished ready this one. Okay, let's continue to the next slide. Radioactivity. Radioactivity அப்படின்னா என்னன்னு நம்ம முதல்ல பார்க்கணும்னா, நம்ம வந்து கொஞ்சம் செஜாராவை பார்ப்போமே. Okay, so I don't know your sejarah, you all learn about Malaysia, pendudukan Jepunலாம் படிச்சிங்களான்னு எனக்கு தெரியல, because I am not teaching sejarah. I don't know. நான் படித்த செஜாராவே எனக்கு அவ்வளோவா ஞாபகம் இல்லை, பட் ஐ நோ லாஸ்ட் டைம் நாங்கள் ஃபார்ம் 3ல படிக்கும்போது நம்ம இதை படிச்சிருந்தோம், பட் ஐ டோன்ட் நோ யோர் சிலபஸ் விச் ஃபார்ம். ஓகே, masa pendudukan Jepun, apa dia ni, sorry, masa pendudukan Jepun ke? Masa pendudukan Jepun, pendudukan Jepun akan ditentang oleh British. Okay. Okay, akan ditentang oleh British. Okay, British akan cakap, okay Jepun, bye-bye keluar dari tanah Melayu. We are going to take over the tanah Melayu. Okay, So you don't have any business here. So the Japan say cannot. So அப்ப என்ன பண்ணுவாங்க உடனே வந்து ஜப்பானுக்கும் இங்கிலீஷ்க்கும் சண்டை வரும்போது ஆஹ், அப்ப என்ன பண்ணுவாங்கன்னா பேர்ல் ஹார்பர் அப்படின்ற ஒரு இடம் இருக்கும் வாஷிங்டன்ல நினைக்கிறேன் இஃப் ஐ நாட் மிஸ்டேக்கன் அமெரிக்கா இட்ஸ் சாரி பிரிட்டிஷ் அட் பேர்ல் ஹார்பர் அது ஒரு இடம் அது வந்து புசாட் பிளாபுஹான்ல அது முக்கியமான இடம் அந்த இடத்த வந்து ஜப்பான் என்ன பண்ணிடுவாங்கன்னா போயிட்டு பாம்பு போட்டுருவாங்க ஓகேயா ஸோ நான் ஏன் இந்த கதை சொல்கிறேன்னா இட்ஸ் ரிலேட்டட் வித் அவர் ஸ்டடி ஓகே ஸோ பாம்பு போட்டுருவாங்க ஸோ அதுக்கு பதிலாக வந்து நம்மளோட வெள்ளையர்கள் அதாவது what do you call the British army they will blast two places at Japan one is Hiroshima I think no Nagasaki I think I'm not so sure with the Nagasaki or not I think Hiroshima and Nagasaki yeah okay Hiroshima Nagasaki I think okay இந்த ரெண்டு கண்ட்ரி இந்த ரெண்டு இடத்தையும் வந்து atom bomb போட்டுருவாங்க okay until now you can see the effect until now ஒரு புல்லு கூட முளைக்கல ஹிரோஷிமால Nagasaki tak payah cakap all the babies that most of the baby that born around this area founded to be defected and many people still dying as a cancer patient till to date okay until now it is happening எதனால இது நடந்துச்சு why does that happen why until now we can see the effect எப்பயோ போட்ட பாம்பு இன்னமும் ஏன் இந்த மாதிரி இருக்கு okay the answer is radioactivity okay radioactivity means ஒரு atom இருக்கு அந்த atom வந்து ஸ்டேபிள் ஆக்கிக்கிறதுக்காக அப்பப்ப அதோட சினாரான வெளியாக்கும் இந்த மாதிரி அதோட ரேஸை வெளியாக்கும் அதோட ரேஸ் வெளியாக்கும் போது பல விதமான பார்ட்டிகல்ஸ் இதுலேருந்து வெளியாகும் ஸோ அது வந்து நம்ம மனுஷங்க மேலே பட்டுச்சுன்னா செல்லில் பட்டுச்சுன்னா நம்ம செல் வந்து மியூட்டேஷன் ஆகும் our cell will be mutated and develop into tumor and soon to become a cancerous cell ஸோ இதுதான் அங்கே இருக்கிறதுக்கு காரணம் அதனால தான் அங்கே இன்னொருக்கும் ஒரு ஃப்ளோரா ஒரு 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 புல்லு கூட முளைக்க முடியாத ஒரு நிலைமை ஹிரோஷிமாவில் இருக்கு ஓகே அந்த சினாரான் இன்னும் வரைக்கும் after that the whole world regret why atom bomb போட்டோன்ட்டு ஓகே although அது வந்து ரொம்ப தூரம் பரவல ஹிரோஷிமா மெயினாக பாதித்தாலும் see the effect we can see until now imagine அது அந்த காலத்துலேயே வந்து எல்லா இடத்துலையும் போட்டிருந்தாங்கன்னா என்ன ஆயிருக்கும் பல நாடு வந்து like tanah perkuburan saja hayat manusia tak sampai 30 kot rasa-rasa lah so that bad lah that's the radioactivity okay இந்த ரேடியோ ஆக்டிவிட்டியை பற்றி நம்ம இன்னும் டீட்டெயில்டாக பார்க்கலாம் பார்த்தீங்களா இங்கிட்ட ஒரு இந்த இதுலேருந்து வெளியாகுது பார்த்தீங்களா இந்த சினாரான்லேருந்து இங்கே காட்டுறாங்க தெரியுதா இந்த மாதிரி தான் சினாரான்லேருந்து வெளியாகுதுன்னு நம்ம சொல்கிறது ஓகே இந்த ரேடியோ ஆக்டிவிட்டி ஃபீல்ட் வந்து நாட் அபவுட் டிஸ்ட்ரக்ஷன் இன் சம் வே we can use it for our own beneficial purpose we will see that how we are going to use it okay yeah
What time we finish class today, sir?
oh 6:10 already yeah
Not
okay
6 o'clock we finish class, sir.
sorry I forget so we will continue about this radioactivity on next class okay so